Guys. Okay, perfect. So again, we did the box problems of 1-7, but then after your quiz on Friday, I didn't push ahead. So this is where we're at. We are doing number 3 and 4, which are essentially sale, tax, tip problems. And then the next part is some textbook problems. So that's why my screen is on the whole thing today, so we can also look at textbook problems. When we do these sale, tip, discount, tax problems, think about the order in which we buy stuff. So if you buy something, they take off the discount or the sale when you first check out. So you like scan an item and then it tells you how much is off of that item. And then after you've done the sale on everything, then they do the tax for your whole order. And this is not applicable in this problem, but there may be one in the future. If you have to tip ever, like if it's a restaurant problem or a food problem or you're tipping for some reason, that goes at the very end. So think about this is the order in which we do things. Sale or discount, then the tax, and then the tip. The sale or discount's a negative thing. You're taking things off, you're paying a little bit less, but tip and tax, you're adding to your bill. So think about whether you're minusing or adding as we go. So this problem says a jumper that normally costs $11.50 is on sale for 30% off. Sales tax is $7. What is the final cost of the jumper? Okay, there's a couple ways that you can do this. So I'm going to kind of piecemeal my way together. I don't do a full formula for this. You can take it bite by bite. So we're going to start by doing the sale of it. So it's 30% off. You can do it one of two ways. You can either figure out what 30% of $11.50 is by doing 11.5 times 0.3, which is 30%, and then minusing that number from your $11.50. So whatever number I got when I did 30% of $11.50, I can just minus it from the total. Or what you can do if you don't want to do those two steps, if it's 30% off, then you're only paying for 70% of that jumper. So instead we can do 11.5 times 0.7, and that gives you how much the jumper is. I'm going to show you that both ways you get the same answer. I would rather only multiply once, so I'm just going to do the 70%. That's the way that I tend to lean towards. When I do 70% of 11.5, I get 8.05. And if I were to do it the other way, where I would just kind of piece it together a little bit more, 30% of 11.50 is 3.45. And then if I minus 3.45 from 11.50, I get 8.05. So either way, you get the same answer. So that's cool. Now that's only the sales price. Now we got to do, that's just the sale. Now we have to do the tax. So tax is 7%. Again, we can do it piece by piece. You can do 7% of 8.05, which is 0.07. And then you can take whatever that number is and add it to the whole price. Remember, sales tax is added to our original cost. So we have to add it to the price of the jumper. I still have to pay for the jumper and the sales tax. Or what you can do is you can multiply your 8.05, so the price after you do the sale of it, by 1.07. The 0.07 counts for the sales tax, and the 1 in the front counts for like the whole price of the sweater. So that's doing this, or the jumper plus the sales price. You can do either way. Again, it will make sense either way. I've had teachers try to teach me like, oh, it's always like 11.5 and it's either 1 plus or minus the price. I can never remember when it's 1 plus or minus. So I like to reason my way through it. Okay, it was 30% off, so that's why I did 70%. Okay, I have sales tax of 7%. Well, I have to pay for the whole thing plus that 7%. So that's why I have that plus. Either way you do it, you're going to get the same answer. So if I did the 8.05 times 1.07, I get 8.61. You can't see because I'm doing it on my calculator, but I'm not rounding on that one because I don't want to go above anything crazy. It's 0.613, and that doesn't affect my rounding at all. If I did it the other way, I'd get the exact same answer. So 8.05 times 0.07 would be 0.56. And if you add that to 8.05, you get the same thing I just got a second ago. It's the same. So a sweater or jumper, excuse me, that's 30% off and has a tax of 7% is $8.61. That's my final answer. Okay, let's do another one. Same idea, but it's $16.95 for the shirt. It's on sale for 18% and its tax is 5.5. Do you guys have a preference whether I just multiply by what's off and by the sales tax, or do you want me to do the piece part together? Anyone have a preference?
I like the just multiply it by like the 0.7.
Okay, so Brooke wants me to just multiply it by like the 0.7 or whatever it is. I appreciate that. Thanks, Brooke. In this case, if I'm doing a shirt that's 18% off, 18% off of 100 would be 82%. So I'm paying for 82% of this sweater or this shirt. So I'm doing 16.95 times 0.82. 16.95 times 0.82. I get 13.90. And then now I have to take into consideration the tax. So my tax is going to be 1 plus, well, 5.5 becomes 0.055. So it's 1.055 is going to be what I multiply this by. 13.9 times 1.055 is 14.66. So my shirt that's 18% off and has a sales tax of 5.5 is 14.66. Any questions? This might feel super elementary, but it's like very basic stuff that I want to make sure that we go over before I test you on anything. So 1.7 is just like a lot of different word problems. And so I believe it's all stuff we've seen before, but I just want to make sure we've talked about it. So any questions on 3 or 4 before I move on? Okay, the next page is word problems from the book. So I'm going to have this up as well. You guys can see both. And we are going to just work through as many as we can. These are all problems that want you to write the formula in terms of just 2 variables. So instead of doing like X and Y, we're going to do like V and R or H and A or whatever. So we'll just kind of see what's going on. It's really helpful to draw a picture. So I'm going to draw a picture in all of these cases, as well as think of what the normal function or equation would be. So all of my answers will be an equation. They're not numbers, they're equations. I'm in my textbook for those of you who want to follow along with your textbook. I know it says page 106, but mine is not page 106. I'm just at section 1.7, and my page is like 148. So if you're following along, it's not necessarily the same as the in-person textbook. Okay, number 15 says the height of a right circular cylinder equals its diameter. Find the volume of the cylinder as a function of its radius. Okay, first thing I'm going to do, and I had to Google this last period because I didn't remember, the volume of a cylinder is V equals pi r squared h. It says write the volume as a function of its radius. So that means that I want V and I want R. I have to rewrite H in terms of something else in order to solve this equation. I only want 2 variables, V and R. Okay, let's draw a quick picture. A right cylinder is like a can. I don't draw very well, but we'll just pretend this is as good as we're gonna get. Circles on top. Straight lines down the bottom. I know it looks a little tilted, but this is as good as we're going to get. If I were to just generally label this, I know that my height is how tall my can is. And then it says its height equals its diameter. Well, we know diameter is like the distance between the 2 points of a circle that goes through the center. So diameter and height are the same thing. Based on the equation that was given to me, I need to rewrite h in terms of r. Well, we know diameter in terms of r, right? We know diameter is 2 radius. It's radius plus radius, or 2r, 2 radius. Well, if diameter equals 2 radius, so does height. So I can think of height as being written as 2r. If I rewrite my height as 2r, oh, now I can just easily plug it in and solve, or simplify at least, simplify it down as much as possible. So I can plug in, v stays the same, pi stays the same, r squared stays the same. The only thing that changes is my h, and it becomes 2r. I am going to multiply. We know that this is a commutative property, so I can multiply in whatever order I want to. So I am going to write 2 and then pi, and then I'm going to write all my r's together. So I've got r squared times another r. R squared is 2 r's times another r is 3 r's, r to the third. And that's it. I'm just writing it in terms of v and r. I did so. I simplified. I'm done. Any questions? Okay. We're going to look at the next one. All of these are different shapes, so you may not remember what the equations are as we go, but I'm going to remind you, and then hopefully we do enough examples that if you want to look at the homework, you kind of know what to look for, or we've done an example like it. This one says the leg of a right triangle is twice as long as the other, right? The length of the hypotenuse is a function of the length of the shorter leg. Okay, as always, let's draw a picture. I drew a right triangle, so it has a right angle. One leg is twice as long as the other. So that means I've got one leg I can call x, and the other one I can call twice x, or 2x. I don't know what my hypotenuse is, so I'll just leave it as h. And it wants me to write the length of the hypotenuse as a function of the length of the shorter leg. Well, good thing both my legs are in terms of x, so that's all that I need to do. I'm going to find the length of the hypotenuse by going way back in your brain and doing Pythagorean theorem. We're going to be doing a lot with right triangles when we get into trig stuff, so I'll remind you of all of these things, but I need us to start dusting off that trig stuff out of your brain because we're going to use it. A squared plus b squared equals c squared. I know that c is my hypotenuse, so that's the same thing that goes in the C spot, but anything else can go wherever we want it. I can put it in A or B. So I'm going to do x squared plus 2x squared. Be sure to put this square outside the parentheses of your 2x squared because I'm not going to just square x. I'm also going to square 2. And then I've got h squared. Now is when I'm going to square. I'm going to get rid of those parentheses. So I'm doing x squared plus 4x squared equals h squared. And I know that I spent a lot of time recently stressing that when you square root both sides, you need a plus or minus, but we're using a real life example of a real life triangle, and real life triangles don't have negative sides. They only have positive sides. So I am going to square root both sides, but I do not need a plus or minus because there can be no negative answers. That doesn't happen in real life. So h equals square root of x squared plus 4x squared. Whoa, what happened here? Now, I know x squared is a perfect square, and so is 4, and so is the other x squared, but since they have a plus sign in between them, we cannot take them out of the radical. They all stay underneath it. So this is my final best answer. Questions so far? You guys hanging in there? Okay. All right. Let's look at number 17. It says the base of an isosceles triangle is half as long as the two equal sides. Write the area of a triangle as a function of the length of the base. Okay, there's a lot going on there. Let's draw a picture and see what happens. Okay, we remember from the depths of our brain that isosceles triangles have the same lengths of their legs. So two of the legs I'm going to label as X. We don't know what they are, we just call them X. It then says the base is half as long as the two equal sides. So the base is 1/2 of X. It's 1/2 of the length of the two other sides. Then it says write the area of the triangle. Well, area of a triangle is 1/2 base times height. Okay, I have my base, I'm good with that, that's 1/2 X, but I don't know my height. And these normal X's don't count as the height. So we actually have to do a little bit of math in order to find the height. The height is if I drop a perpendicular from the top corner down to the base. So this is what I call my height. But now I gotta do a little bit of math to figure this out. If I look at just this green triangle, I have one side is H, one side is 1/2 X, and one side is X. We need to get at H in terms of X. So we got to do another Pythagorean theorem. However, this time H isn't by itself on the side of the equal sign, X is, because X is my hypotenuse now, the side across from the right angle. So I'm going to do H squared plus 1/2 X squared equals X squared. Again, I have to do this because I need H in terms of X, and it's not in terms of X yet. Now we're just doing algebra. H squared has to stay the same. I square my 1/2. Well, that's 1/4. I square my, ooh, no, I messed up. I messed up because 1/2 X is the whole base. If I'm doing 1/2 of that for this side, it's only 1/4 X. When I plug in 1/4 X squared, it becomes 1/16 X squared. That's my fault. Let me say that one more time in case you missed it. 1/2 X is the entire base. I only want half of that base though, so half of 1/2 is 1/4. So this little bit right here is 1/4 X, not the whole base, which is 1/2 X. I did have to square that 1/4 X, so now it's 1/16 X squared equals X squared. The only thing we have to do now is get H by itself, so I'm gonna minus that 1/16 X squared from both sides. And I get H squared equals, well, 1 whole X squared minus 1/16 X squared is going to be 15/16 X squares. And I need to radical square root both sides. H is equal to, well, the X squared becomes an X, and that 16 on the bottom becomes a 4. Those are both perfect squares. That was easy. I dealt with that. I dealt with that. What I haven't dealt with is the root 15. That just doesn't simplify. That's just going to have to stay as a radical 15 because I cannot simplify that anymore. That's as good as it gets. My height, if I want to represent it in terms of X, is radical 15 over 4X. So I'm going to go back to my main picture and write radical 15 over 4X in for my H. That is my height. I'll even write it off to the side if it's a little messy for you. My height is equal to radical 15 over 4X. Okay, now that I did all the hard work to find that, now I'm going to plug my pieces into my area. I do still have my base, 1/2 X. Again, now I'm using my whole base because I'm doing the whole area of the whole triangle, whole base. And then my height is root 15 over 4X. Area equals 1/2 X root 15 over 4X. I just got to multiply everything together now. 1 times 1 times root 15 leaves me with a root 15 on top. 2 times 2 times 4 leaves me with a 16 in the denominator. And X times X gives me X squared. So area equals root 15 over 16 x squared. All right. Questions on that one? That one's a little bit of work. Okay, I want to do one more. Do I need to stay here for a second or can I move on? I'm going to take that as moving on. Stop me if I'm moving too fast, but I'm going to move on, okay? The last one we're going to do is number 18. Also, sorry I'm messy with my work. Hopefully you could keep yours a little bit more organized. I'm going to scoop this up. Actually, no, I'm not. Whatever, it doesn't matter. I'll erase it later. Number 18 says a square is inscribed in a circle. Write the area of a square as a function of the radius of the circle. Okay, a square is inscribed in a circle. In order to solve this, we need to know that the word inscribed is exactly as it sounds. It sounds like inside. If it's inscribed, then it's inside the other shape. So a square is, if I replace inscribed with inside, I'd say a square is inside a circle. Okay, I can draw that. I got a circle, and I've got a square on the inside. All right, that's as good as we're going to get. This word is not used today, but you could see it in the future. The word circumscribed. That sounds a lot like circumference, and that means we're going around or about or outside. So if you see the word circumscribed, it's about or around or outside. Just a bunch of prepositions versus inside versus outside. So just, again, not this problem, but you may see that in the future. So squares on the inside, we want to write the area of the square as a function of the radius of the circle. Well, we know the area of a square is whatever the side length is squared. So we just have to figure out what the side length is in reference to r. We know r, the radius, goes from the center of the circle to any point on the outside. So it could be here. It could be literally anywhere along the outside. We want to put it somewhere that makes sense or is helpful to us, which, ooh, right here would be helpful. All of the radius is in the square. If I drew another radius from the center to this point over here, now I have two lengths that are both r, and they're all inside the square and all inside the circle. I can use those to find this side length, and if I know one side length of a square, I know all of the side lengths of a square. Now, you might have blacked this out from geometry because I know that happens sometimes, but in a square, this is a right angle. And now I have a special triangle. It's a 45, 45, 90. It's a special right triangle where those two sides are the same, and that means its hypotenuse is the side length times radical 2. Again, you might have blocked that out of your memory. However, that's going to be super important when we get to trig, so I'm bringing it up today. It's a right triangle where two sides are the same length. It's an isosceles right triangle, so that's a r root 2. Well, if one side of a square is r root 2, then all of them are r root 2, r root 2, r root 2. So my area of a square is just the side squared. Well, my side is r root 2. So r root 2 squared. We got to square my r and we got to square my root 2. R squared is just r squared. And root 2 squared is the same thing as positive 2, just normal 2. So area of a square inscribed in a circle is 2 radius squared. Okay, as you can see, we got a couple more of these we need to do, and then we've got some more word problems that we're going to approach tomorrow. I'm going to stop sharing my screen now. If you have any questions,